Hi, welcome to Naresh IT. This is Kishore and today we are going to continue the cout and scene examples. Okay. In C++, we are using cout and scene for standard input output operations. In last session, we have discussed how the cout is working. Today I am going to give how the scene is working. Generally, scene which is equivalent to scanf function. Now, what are the differences between scanf and scene? Now, I am going to explain first of all how the scene is working. Generally, scene is a predefined object, whereas scanf is a predefined function. Okay. Here scanf is a predefined function and scene is a predefined object, and scanf belongs to stdio.h and scene belongs to iostream.h. And here one point is scene is a predefined object and every object is having corresponding, and here scene belongs to or scene is the object of iStream class. And the major difference between scanf and scene is, okay, the first thing, it is a function, it is a object, it is the first thing. And second one is, in scanf we should have to go for address, okay, and scene does not require any address. Okay. The major second difference is what? In scanf you should have to provide the variable address, but scene does not require any address. And third difference is, scanf always requires conversion characters. Scanf always requires conversion characters, but scene does not require any conversion character. Scene does not require any conversion character because of implicit conversion is there. In scene there is an implicit conversion, that is why they does not need it. Okay. Now, I am giving one practical example, okay, based on both scanf and scene. Okay. Suppose now I am going to write a first C program. Okay. I want to read two integer values and later I want to perform addition of those two integers. Now, the program is, I want to perform the addition of two integers. Then first I am giving C example, later I am going to go for C++. Now watch this. Okay. First of all, common header files stdio.h and conio.h. Here the point is stdio.h, we are going to use printf and scanf in our program and their header file stdio.h, and conio.h, here we are going to use clr, scr and getch and they belongs to conio.h. That is why I have taken two header files. Later void main, and later in C language there is a rule. In C language there is a rule. What is the rule? Means the variable should have to declare at the top of the program or first line of the program. That is why first declare the variables int a comma b, later s. Here S stands for sum. Here a and b are going to read some values and the sum is stored in sum s. Later clr, scr. Now the screen is cleared. First of all, we are going to read some values, later we are going to store the sum in s. And now first of all, what we have to do? We have to read some numbers. That is why printf. Here p stands for, just assume printf, and enter two integers. Now I am going to write like this, printf enter two integers, now semicolon. Next scanf required, s means stands for, okay, here s means scanf. Now two integer values, now when two integers are there we have to go for conversion characters, and integer conversion character %d, %d, ampersand a and ampersand b. Okay. Here what happened, watch it. Now ampersand a means address of a and ampersand b means address of b. Now what happens when this program is executed? Just think it is the stack, and now two variables are created, a and b. Now here scanf we have used. Now when scanf is used, first of all the input means first value is stored in a address, means here. Now for example 10, later second value b address, it is going to store in b address. Now two values are stored in stack. Later we have to perform the sum. For that we have declared one more variable s. Now in s we are going to store the a plus b value, that is why expression s equal to a plus b. Now what happens here, the two values are added and the value is going to store in s, that is why s value becomes 30. Now the s value becomes 30, that is nothing but a plus b value. Next printf, here I am going to perform sum equal to percentage %d and where the 30 is stored in s address, that is why yes. Now the sum is going to print here and get ch. Program is waiting for the input. When this program is compiled and executed, automatically it is waiting for two integers. Later after entering the two integers, it is automatically printing the sum. And here watch it, here I have used a scanf function and here %d are called conversion characters and ampersand a ampersand b represents address of a and address of b. That is why after execution of this program, it is going to read two values and it is performing the sum. And here the point we have to observe is, in scanf these conversion characters and address is mandatory. Suppose the same example in C++, I am going to conduct the same example in C++. Now watch this. Okay, in C++ to perform the same example, we are going to use cout and cin. Now cout and cin are the predefined objects available in iostream.h. That is why first iostream.h, now common thing iostream.h, because of here I am going to use cout and cin. Next clr, scr and get ch common, that is why conio.h. Later we need the variables, and here the major difference between C programming and C++ programming is, here in C language the variable should be declared at the top of the program, but in C++ we can declare the variables at any place. That is why directly I am going to start clr scr. Now the screen is cleared. Later we have to input some values. For that, first of all we have to declare the variables. That is why here I am going to declare int a comma b. Now two variables are declared. Later we have to read some content for this a and b. That is why cout this time I am going to use cout enter two integers. Next cin this time. Okay, here cout is the output and cin is for scanf, means cout is equivalent to printf and cin is nothing but scanf. Okay, that is why here printf scanf, but in the form of objects. And here the most important thing, in scanf conversions are required, but cin does not require any conversion. That is why directly a, next b. Now what happened, when the values are entered, first value is stored in a and second value is stored in b, but here implicit address and conversion taken. That is why cin does not require any conversion or address. Okay, now the values are stored same to same. Later int sum means int s equal to a plus b. Now watch this, just before we have discussed that in C++ we can declare the variable at any place of the program. That is why I have declared int s in middle of the program. Okay, in C++ we can declare the variables at any place of the program. That is why I have declared the variables in middle of the program. Next int s equal to a plus b. Now the sum is going to store in s. Later I want to show the result, sum equal to s. That is it. Now first of all what happened, sum is going to print sum equal to, later s value is what, 30. Now sum equal to 30 is going to print on the screen. Now program finished. That is why I am going to close with get ch brackets close. Now watch the differences. Here I have used printf, here I have used cout, and here I have used scanf, here I have used cin. But the difference is, here in scanf conversions are used and address also used, but here in cin there is no conversions, there is no address operator. Okay, like this the program is going to execute. These are the major differences between cout scene and printf scanf. That means cout printf and scene scanf. Okay. Now we are going for another concept. Now we are going to start another concept. Now we have finished how to work with cout and scene. Now all the control statements of C language are nothing but C++ statements. That means what? Generally in C language we are going to use okay, three types of control statements. One is what? Branching statements, second one conditional control statements, third one loops. And in C++ also we are using the same thing, okay, branching statements, conditional control and looping statements. Under branching statements generally we are using go to label, break, continue, return, exit. Okay. Under branching statements we are using first one is go to label, which is also called jumping statement. Next one break, next one continue, next one return, next one exit. Now watch this. These five are called generally branching statements. Okay. Next we are using another one, conditional control. Under conditional control we are using the simple thing everybody knows. One is if and second one is switch. Okay. We are having two types of conditional control statements. One is what? If, second one is switch. Under if condition once again we are having, means we are using four types. One is simple if, second one is if else, third one is if else if, which is also called ladder if, and last one is nested if. Now these four are called if conditional control statements: simple if else if or ladder if, and next one is nested if. And under switch, okay, there is no categories, directly we are going to use switch statement. Now they are called conditional control statements, and along with these we are going to use loops, which are also called repetitive statements or iterations. Okay, loops which are also called iterations. Now looping statements or iterations or repetitive statements. Under loops basically we are going to use two types of loops. One is entry control loops, next one exit control loop. Okay, we are having basically two types of loops. One is entry control loop, another one is exit control loop. Under entry control loop we are using while and for loop. Under exit control we are having only one, that is do while. Okay, here under loops we are having two types, entry control loop, exit control loop. In entry control loops what happened? First condition, later statements are executed. But in exit control loop first statements are finished, later program is going for conditional part. That is why here it is entry control loop, it is called exit control loop. Under entry control loop we are having while loop and for loop. Under exit control loop do and while. And now the same thing we have used in C language also, and their work also similar in C++. Okay, that is why there is no variation, both are used for controlling the program. That is why they are called control statements. And now we are going to start dynamic memory allocation in C++. How the memory is allocated at runtime. Okay, to store anything in our computer, first of all we should have to allocate the memory. Okay, to store anything in our computer, first we have to allocate the memory in computer. Now the memory allocation is conducted in two ways. Okay, we are having two types of memory allocations. One is static memory allocation, which is also called compile time memory allocation. Second one is dynamic memory allocation, which is also called runtime memory allocation. Now what is called static memory allocation, what is called dynamic memory allocation? Now first of all I am going to give one small example why we need the dynamic memory allocation. Okay, to know about the dynamic memory allocation, first of all we have to know what is called static memory allocation and what is the problem. Okay, I am giving small example. Suppose int of 10, generally it is called array, and here int means data type and a is the variable and 10 indicates the size. Now after executing the program, what happens, your system allocates 10 integers memory in the stack. Now each integer requires 2 bytes, and here how many integers I said, 10 integers. That means in memory total 20 bytes are allocated. Okay, and here, okay, now what it is, blocks. Now how many blocks are created, 0 to 9 blocks. Okay, that means totally 10 blocks are created, totally, just assume totally 10 blocks are created, and each block size is what, integer, na, that's why 2 bytes, that's a total 20 bytes memory allocated. But here I am going to enter the values like this, suppose 5, 9, 22. Watch this carefully. Here when the program is executed, what happened, 20 bytes memory allocated or 10 blocks memory allocated. But here how many elements you are passing, only 3. Actually 3 elements require how many bytes, 6 because of integers, but we have allocated 20 bytes. That means remaining 14 bytes are getting wasted. Next, suppose there is another situation, I have created, okay, int of 2. Okay, now int of 2, when it is executed 4 bytes memory allocated, but here you are trying to store. Now what happens, here you are trying to store 3 values, now it gives error. Okay, it gives error, why, because insufficient memory, you are able to store only 2 values, but you are going to store 3 values. That is why here array size is always static. Okay, here remember this, array size is always a static value or constant integer value. That means what, at runtime we are not able to increase or decrease array size, because of array size is always constant integer expression or value. Okay, and due to this what happens, sometimes we are getting memory wastage, sometimes memory shortage. Okay, here memory wastage and here memory shortage. Okay, and here when the memory is decided, okay, programmer is going to type the program first, means programmer is going to complete the program first, later he is going for compilation process. Every program should have to compile, na? When compiled the program, means when the program is compiled, compiler reads the size first. Here how much the user specified, 10, that is why it creates a 20 bytes indicator, means when this program is compiled based on 10. Okay, now the compiler understands user requirement 10 bytes, now it is going to say 10 bytes required for the user. The same code is passed to execution. In execution time the OS reads this message, what it understands, user requirement 10 integers, that is why at execution time it allocates 20 bytes. Okay, due to this what happened, compiler decides the memory and OS allocates the memory. That means here memory controlled by compiler but allocated by OS. That is why this memory allocation is called compile time memory allocation, which is also called static memory allocation. And now what happened, with this we are getting memory wastage or shortage. That is why to prevent this problem they have introduced dynamic memory allocation, which is also called runtime memory management or runtime memory allocation. Now in dynamic memory allocation what happens, instead of array concept we are going to use pointers. Okay, here we need the pointers. In runtime memory allocation we should have to use pointers, then only dynamic memory allocation possible. In dynamic memory allocation what happens, at runtime, not compile time, at runtime user enters the size. For example, my requirement 5 integers, then I am going to enter 5, immediately the memory is allocated. Immediately when it is allocated at runtime, already user entered the value at runtime, memory also allocated at runtime. And in previous example what happened? At compile time means at designing, when source code is designed the size is mentioned. In source code this time means in dynamic memory allocation, okay, in source code we are not mentioning the size, it is the important point. In static memory allocation what happened? At compile time or when the source code is designed we are mentioning the size, but in runtime memory management or dynamic memory management or dynamic memory allocation what happens? In source code we are not entering any size, at runtime we are entering the size. Based on that user request, immediately the OS allocating the memory, that is why it is called runtime memory management. Now the total memory is dependent on user input, that is why there is no chance for memory wastage or shortage. And now here to conduct this dynamic memory allocation we should have to use pointers. Without pointers there is no dynamic memory allocation. And next, here one interesting thing is, generally in C language for dynamic memory allocation we are using functions, because of C is a function oriented concept. C is a function. What are the functions we are using? malloc, calloc and realloc. Okay, here in C language for dynamic memory allocation we are using the functions malloc, calloc, realloc. Okay, and of course var malloc, var realloc also there. Okay, and now in C++, instead of all these functions they have given one operator called new. It is the difference. In C language for dynamic memory allocation we are using malloc, calloc, realloc functions, but in C++ we are going to use new operator for dynamic memory allocation. As usual, to deallocate the memory in C language we are using free function. Okay, here what they are doing? Allocating the memory. Now I want to use the same memory in next program or continuation, then we have to deallocate the memory. For that we are using free function in C. Instead of this in C++ they have given delete operator. Okay, in C++ delete operator is used to clear the memory occupied by these functions. Okay, and here in C language we are using functions, and here in C++ we are using operators. New and delete operators are used for memory allocation and deallocation. Okay, in next session I will explain how the new and delete operators are working with example.